Assalamualaikum and hi. So today our team will present the assignment 1, which is we need to solve the engineering problem by using the intelligent control system concept. So I will introduce myself and our team. My name is Muhammad Najmi Zikry bin NAZRI. My metric number is DE170140. Second is SYAZWAN bin RAZAK, DE170098, and lastly Muhammad IKMAL bin Muhammad TAIB, DE170115. And so we go to our first training algorithm, which is the perceptron training algorithm. So according to the question, training concept top to bottom, this is provided from the question. And then for this perceptron training algorithm, we assume the B is 0.5 and N we set initial value we set 0.1, and W1, W2, W3 we set 1. So this is a formula that we use in perceptron training algorithm, which is the learning rate is 0.1, and sum S x1 W1 plus x2 S2 x2 plus x3 plus BO. This is a bias. So the rest is a new weight Wn. Wn equal Wo plus N time Xi time T minus S. Lastly is a new bias Bn equal to Bo plus N T minus S. So next we go through to the this part, which is this table. Before this I said we set all this value, which is W1, W2, W3 is 1 and bias is 0.1. So this is a table, and 0, 0, 0 and 0, 1, 0, 0, 0, 0, 1, and B is 1, 1, 1, 1, 1, 0, 1, 0, 1. So first we need to find the summation, which is this S. So according to previous formula, for sum we need to use this S x1 W1 plus x2 plus S3 times S3 plus dengan BO. So this x1 times W1 plus x2 times W2 plus x3 times W3, and lastly plus 5, which is 0.5. So the summation we get a 0.5, and then the 0.5 to determine the T we need to determine the Y we need to T minus S. So T minus S we get negative 0.500, which is when they less than 1, the Y will turn into 0, and after when they turn into 0, all the value up there will keep remain same. So W1 is 1, W2 is 1, W3 is 1, and also bias 0.5. So next we go to the second row, which is 0, 1, 0. So the summation we get the 1.5, and then 0 minus 1.5, 0 minus 1.5 we get a negative 1.5. So negative 1.5 we get 1, and then the value W1 is 1, W2 is 2, WT is 1, and bias will 0.4. So the rest will also use the same value and same formula, and they will get this all value. So next we go to bottom to top. Also bottom to top are same to the top to bottom, but the value of t, this value of t are different. Before this, value of t is from 0 to 1, and then for this value will 1 to 0. So we'll do the same formula. We'll do the same calculation. The same calculation, same to top to bottom. For this, x1 times w1 plus x2 times w2, x3 times w3 plus 0.5. So the summation we get is 2.5, and then 2.5 1 minus 2.5 we get 1.5, and the value y is 1. So when we have y and t is equal, so the value w1, w2, w3 remain same, and also bias is remain same, and then this all the value that we have.
Okay, for the accuracy check, we are going to take the input of x1, x2, x3 and the target to get the y prime. So for the x1 is 0, 0, 0, 1, 1, 1. For the x2, we will get 0, 1, 0, 1, 1, 0. For x3, 0, 0, 1, 1, 0, 1. For the t, 0, 0, 0, 1, 1, 1. Okay, for this perceptron, we are going to assume that the f is greater than 1, greater and equal to 1, otherwise 0. So when we plus the x1, x2, x3 and the bias, if we get greater than 1 or equal, then the y prime will be 1, otherwise it will be 0. Okay, so for the first one, it is 0 plus 0 plus 0 plus bias 0.5, that we will get 0.5, and then the y prime will be 0 because it is not greater or equal to 1. For the second one is 0 plus 1 plus 0 plus 0.5 will be 1.5, that is greater than 1, then the y prime will be 1. For the third one, 0 plus 0 plus 1 plus bias 0.5, we will get 1.5, then the y prime will be 1. Then 1 plus 1 plus 1 plus bias 3.5, we will get the y prime 1. Then 1 plus 1 plus 0.5, that we will get 2.5, that is greater than 1, so here we put 1. Finally, 1 plus 0 plus 1 plus the bias 0.5, we will get 2.5, and then we will put the y prime here 1. Okay, after that, to plot the graph, we need to input the value into this formula. So the formula is x3 is equal to theta minus x1 times w1 minus x2 w2 minus bias divided by w3. The value of w3 here is 0.9. For the x1 and x2, we are going to give it a constant range, that is -3 to 3. So to get, after we fill the equation with the number that we have, we will get for x3 is 6.4444, The second one is 4.3333. The third one is 2.2222. The fourth one will be 0.1111. The fifth one will be 2. The sixth one will be negative 4.1111. And the last, negative 6.2222. Okay, to find the theta range, as we know, we are given two class, that is class A and class B. So here we need to see which, for the class 1, we need to see which of these three is higher. So the higher one is 1.5, and for the class B, which is the lowest, that is 2.3. So we take it and make it as a theta range. That will give us, the range is 1.5, theta is less than theta, and theta is less than 2.3. To find the theta value is simply by subtracting the value of 2.3 minus 1.5 and divided it by 2. That will give us the value of 0.4. Okay, we open the MATLAB and we insert the input for X, Y, and Z, and then we are going to plot by typing the scatter tree X, Y, Z. Then we are going to label each of the axes for the X1 axis, the X2 axis, the X3 axis, and the title. So we will get the graph as follow, and we check the graph, the value of the graph. The first one is 6.444, second one 4.333, the third one 2.2222, the fourth 0.111, negative 2.0, negative 4.111, and also negative 6.2.
Hi, my name is Muhammad IKMAL bin Muhammad TAIB, and my CAP metric number is DE170115. Today I will explain about the other line training algorithm. For the input that given for this assignment is 0000111 for the x1. For the x2 is the 010110. For the x3 001101. We assume for theta in this assignment is 000 for the class A, 111 for the class B. And for the N learning rate, N we assume as 0.1. From the table below shows that the data that given for this assignment will be put into the x1, x2, and x3. For the sum, the total, the formula that used is x1 times w1 plus x2 times w2 plus x3 times w3 and plus b bias. So for this, to find the data that we assume we will put into this column, which is 000111. For the theta minus s, we'll get from this both column, which is theta minus total. To find the W1 for W1 for the first year, first iteration, so the formula that given is W new equal to W old plus n, and from this, and then minus by xi times theta minus sum, and then this formula will be used also for the W2, which is using the x2, and for the W3 using the s3. So for the bias, the formula is used is for B new equal to B bias all plus N times theta minus sum minus total. Then we'll get the value for this bias, and then for the other we'll be using the same formula for each row until get the final answer. For the W1 is 0.726, for W2 is 0.619, for W3 is 0.641, for the bias is negative 0.100. Okay, for the accuracy checker, the formula that we use for this accuracy is W1 Wx1 times W1 plus X2 times W2 plus X3 times W3 plus B naught, B bias. So we put the calculation, we put the input that given with the theta value, and we'll get the value for the y prime. Y prime that used is for this formula that use input the data in this y prime. For this, if the value of the y prime is lower than 1, so it will become 0, and then if the value for the y prime is more than 1, okay, so it will consider as 1. So the accuracy for this value is 100%. 3, 2, 1, action. The next step is to find the different range for the data. So for this data that got we will be use the formula. Is the for cluster 2 minus cluster 1 divided by 2 plus cluster 1. So for the cluster 1 that we use is, for the cluster 2, cluster 1 that we use is 0.52. Okay, for the cluster 2 we use is the minimum value is 1.25. Okay, from that we get the answer for this theta is 0.89. With this data, we'll be construct the graph using this data based on the formula for other line. Okay, for this value, for the other line value, formula we use is x1 w1 plus x2 w2 plus x3 w3 plus bias is more than theta. So we use that, we convert it to the x1 w1 plus x2 w2 plus x3 w3 plus bias equal to theta. So the value that we use is for this other line is this one that I already highlight it. Okay, we will put the data into the formula, which is a 0.73 x1 plus a 0.62 x2 plus 0.64 for x3 and minus 0.1 equal to 0.89 for the data. And then we'll be simplify the formula, and we'll be gather for the x3 is a 1.55 minus 1.13 for the x1 1.13 x1 minus 0.97 x2. So for the calculation that we use, 3, 2, 1. 3, 2, 1. For the other line graph, the formula for the S3 we get the constant value for the x1 and x2, which is this is the constant value, and then we'll only need to find the S3. Okay, for the graph, I have plotted into the MATLAB. Okay, this is our coding. Okay, so we will need to wait for a while. Okay, so this is our graph for the other line method. Okay, we can find it, the value. Okay, and this is for the other line graph that plot from the MATLAB. The next is we'll need to find the retrain for the other line, which is from the bottom to the top. Okay, for this one, we just shuffle the input from the bottom to the top. So for the S1, we'll put the value 111 and 000. For the X2, we put the value for input is 011 010. For the S3, we put 101100. So the formula is also same for the sum. Okay, for the sum we use the x1 w1 x2 w2 x3 w3 plus bias. Okay, the formula is the same as the other line. Theta minus sum also same. Okay, so to define w1, we need using the same formula which is wn, w new equal to w naught plus n times x. Okay, x1 for the w1, and then times theta minus sum. And then for the x2, we use for the x2 w2 we use the x2, for w3 we use the x3. So for the bias we use formula is the bias new equal to the bias old plus n times theta minus sum. Okay, we'll be continue for the formula for retrain at the line. So we use the formula x1 w1 plus x2 w2 plus x3 w3 plus bias more than theta. So we simplify it to get the value, and this formula for the retrain at line, we use the value from this bottom to top table. So we have a 0.561 for w1, 0.641 for w2. For the w3 we have 0.607, and for the bias we have negative 0.075. Okay, with this data will be simplified until we get the x3, which is the 1.596 minus 0.924 x1 minus 1.056 for the x2. Okay, so the formula that we use we'll put into this column. Okay, for the x1 for the s1 and s2 we have the constant value. Okay, so we continue with the MATLAB. Okay, so the coding I already saved. I already have. Okay, and now Let's pause it. And so what we have for this plot, scatter plot. Okay, we need to wait for a while. Okay, so this is the scatter PD scatter between other line. Okay, this is scatter. Okay, so we find the value for this. Wait. For the value for this between other line.